Here we are, kids, 1 week until we start looking at the 2 days for next week, and then we head into a very fun time of the year. We get a break, hang out with our families at home, and enjoy ourselves. Let's knock out this physical versus chemical changes and get those things explained rather thoroughly. If you have the codes Nearpod, I'll make sure to put those in. We will have a chance for us to play a quick quiz. We did that in class today, so I have some good data on most of the people who were in class. There's a few people who missed the Zoom today, so I'll post this online for them to do. You will need to watch this video as well. This video from Study Jams does a fantastic job of describing the differences between chemical changes and physical changes. It gives you all the information you would really need to have a basic understanding of that. And so we are going to talk about physical changes. Physical changes, when you change something physically, you are not changing what that object is. For example, if it's a piece of paper and you ball the piece of paper up, it's still paper. If it's some wood, like a tree, and you chop the tree up into some logs, it's still a tree. If it's a pencil and you stick the pencil in the pencil sharpener and there's all those shavings inside of the pencil sharpener, it is still a pencil. You have not changed anything of that object as far as like what makes it up. It's not a new substance. It's the same substance that's just been changed physically. So we took some notes on our anchor chart here that looks similar to this. And basically what we're saying here is a physical change does not change what the matter is. There's not a new substance formed. I can cut, tear, color, crumple, smash paper. All of those things do not change what the actual substance is. Now, we may even have evaporation, which is liquid to gas. We might have condensation, cloud formation, which is gas to liquid. We might have freezing point, when our liquids turn to solids, or the melting points, when our solids turn to liquids. We can even have fun like we did in class last week and have sublimation, when solids turn directly into a gas, or watch the frosty time lapse when frost forms on a window and have gases turning directly to a solid. And although all of those things seem like they are changing into something new, if you think of it in terms of water, in none of these instances are you getting a new substance. These are all physical changes. Why? Because they stay the same substance. In each change. There is no change whatsoever in what the substance is. So if it's water, if you take water and you boil it, whether you have the water in the pot or the steam, if you were able to look at the molecules, the only difference is the molecules are a little bit further apart in gas than they are in liquid, but the molecules are still water molecules. If you watch condensation, like if we were able to go up into the sky where there's cloud formation and watch this gas turn into a liquid, little tiny water droplets, if we could see the molecules, we would see that the molecules go from being very far apart to kind of close together in those water droplets, but it's still water molecules. Whether I change liquid water into a solid and have my molecules get very close together, or I change a solid into a liquid where they become a little bit further apart. And even when I do something as crazy as a solid to gas where, boom, they go from super close to super far away, in none of these instances have I created a new substance. They are always water. And because it stays the same substance, it's a physical change. Now, we may even be able to show off our mad scissor skills and cut something out of a piece of paper, but here's what we need to understand. This piece of paper is still paper. I just changed the shape and the form of it, and even the pieces that I cut out are still paper. I know that it would be very hard, almost impossible for me to put that back completely, and I know people get that confused. Well, if you can't change it back, it's a chemical change. That's not always true. You need to ask yourself all of the questions involved. Number one, can I change this back? Could I change this back into a whole piece of paper? Let's be honest, probably not. But then the very next question you need to say to yourself, well, if I can't change it back, is it still the same substance? Is it still paper? Or when I cut it, did it turn into something new? and because it's the same substance, it's still paper, we're going to label that a physical change. The one that trips people up the most is the one that I went over on the anchor chart. When you change your state of matter, it is very easy to look at an ice cube turning into a liquid and say that's something new. It's a new state of matter, yes, but is it a new substance? No, it is still water in one of its three states. You've not changed anything chemically with it. You have not made a new substance. When I melt an ice cube, it doesn't turn into something new. It just turns into the liquid form of water. So when we're changing states, we're not changing it chemically. We are changing it physically. One that gets a little tricky is when we start to dissolve things. So if I were to dissolve sugar inside of water, it is very easy for me to say, oh, you formed something new, Mr. Bowens. Now you have sugar water. And I understand that. But we need to think, can I undo this? And if we were able to look at it chemically and get on the molecular level, we would realize that the sugar molecules and the water molecules have not changed. They are actually just kind of flowing around and bumping into each other. The sugar molecules are in the water. They've dissolved into the water, but they have not chemically bonded with anything in a way that we can't break apart and change back. If I boil a pot of salt water or sugar water, the water evaporates and there are actually remnants of the salt or the sugar left behind in the pot when we finish that. So technically I can undo that. So we would label those as physical changes. And that's one that people get mixed up pretty often. We move on to chemical changes, and you can see this piece of paper burning in the background. Now this is different than me ripping and shredding and coloring and folding a piece of paper. Once I've burned it, I have to ask myself, number one, can I change this back? No. Is it still paper? No, I have ash and paper. Ash and paper are not the same thing. Let's take a look at our anchor chart for chemical changes. A chemical change is a change that causes a new substance to be formed. If you burn something, you're forming a new substance. If something rusts, it is a new substance that's been formed. It's not just a discoloration of the metal. It's a new substance that's forming on the metal, and that's very, very important to understand. We do have some signs of chemical change. So let's just take, for example, ripping up a piece of paper. When I rip up a piece of paper, are there any gases that form? No. There's no gas that forms when I rip paper. Is there any light emitted? Is there a light given off by ripping paper? No. No, there's no lights given off. Is there a temperature change when I rip paper? No, not necessarily. Is there a color change? No. And let's just say even if we colored paper and ripped it, all right? Now I got to say to myself, is a new substance formed? No, it's still paper. Still paper. So ripping paper is a physical change. A physical change. You might want to start thinking about some other things, and we'll go through that here in just a moment, and then asking yourself these same questions. So we take a look at this beautiful cake, and I probably should try to make this cake. It would be like the TV show Nailed It, if you've ever watched that on Netflix. I'm sure my unicorn would look very pitiful. It would be the saddest My Little Pony in the entire world. But let's think about baking a cake. Okay, you get your eggs, sugar, flour, and your other things together. You put them together, you make a batter, and you put the batter in the oven. And now we need to think of it like this. Number one, has there been a gas formed? And you might initially say, no, Mr. Bowens, there's no gas formed. But I want you to kind of close your eyes, slice off an imaginary piece of that cake, flip that piece over on your plate, and stare very closely at the cake portion. Can you see the spaces that are in there in that spongy cake in between each other? Those are actually made when gas forms in the creation of your cake. So is there a gas formed when you bake a cake? Yes. Is there a light emitted? If there's light coming out of your cake, you probably don't want to eat it unless it maybe some candles burning on top for a birthday. But I'm saying if you're cooking it and it's emitting light, you may have cooked it too long. Is there a temperature change? Well, in order to have a cake bake, yes, there is a definite temperature change. Is there a color change? Well, let's think about it. I have this very, very light, almost white colored batter. I get my cake out depending on what else I put into the cake, and it can be a light brown to a dark brown depending on how long I cooked it. So there is a color change. And then we ask our big question. Can this be changed back? Can I change this piece of cake back into eggs, sugar, and flour and other things? No, I cannot change it back. So it fits most of the criteria here. It can't be changed back. So when you look at baking a cake, you have a chemical change. Some other signs of chemical changes when you have a change of color. Fireworks, there's a huge change of color, right? They explode, there's beautiful colors in the sky. But you don't want to always say just because there's a change of color, because I can color a piece of paper with a crayon, or I can paint a car. That doesn't mean it's changed. Now, if I see rust on a car, that is a different color. That's a color change, and it is a chemical change. So be careful with the whole color change. One other thing we can think about is there an odor? So let's go back to our cake. When you're making a cake, do you pretty much know it the moment you walk into somewhere if they're baking cookies or making a cake? Yep, smells pretty good to me. Or it could be a bad thing. If you talk about milk spoiling, well, spoiled milk does not have a very pleasant scent, but there's definitely a scent to it, and there's some gases that are formed in that. So changing that's a chemical change when milk spoils. You may have exothermic, like heat production. You may have endothermic, loss of heat, and we'll do some experiments with both of those in class. So you check to see if there's a temperature change. And last, you check, again, like we said, is there a release of gas? If those things are happening and you have created something new, you now have a chemical change. One that's a little bit tricky is this. If I drop an egg on the floor, just a regular egg, I've done nothing to it, that's a physical change. All I did was crack the egg. Now, like Humpty Dumpty, I can't put it back together, but it's still an egg. When you fry an egg, you have changed the proteins of the egg permanently. It cannot be undone and changed back to its original state. Yes, it's still egg, but you can't undo it. Is there an odor when you cook eggs? Yes, there is. Do you need a heat to change that? Yes, you do. So you have a gain of heat. You have a change in color. It goes from that clear to white or even yellow if you're scrambling up your eggs. And you have an odor. And you can't change it back to its original state. That is going to be a chemical change. A chemical change. That's the one that's a little bit tricky when we get into that. There's a quiz for us here at the end. But that is all we did essentially for today for the notes. We did go over, not here, we went over this for our project about states of matter. You have solids, liquids, gas, chemical change, physical change. I've already done the solid slide for you. So you'll notice here, your slide should have the following, an example. Okay, well, ice is an example of solid, so I did that. You should have the vocabulary word and definition. A solid is a state of matter with a definite shape and a definite volume. That's right here, so I have fixed this one as well. I need to have gifts. I have 1, 2, 3 gifts that show different states that solids might be going through. For states of matter, like solids, liquids, and gas, I need to tell you how they can move from one state to another. Solids can change to a liquid when you add heat. This is called melting point. So I've got that. Solids can change into a gas through sublimation. And then I said when ice changes in either direction to a gas or to a liquid, it's a physical change because it's still water when it changes in all 3 states. So that fills in this last part. So I actually did solid for you. So you have liquid, gas, chemical change, and physical change. So 1, 2, 3, 4. Mr. Bullens wire there 20, just in case somebody does some extra work. If you have any questions on that, again, we're going to go over that again tomorrow when we have our time in class, because we're going to continue to work on that together in case my remote kids have any questions. Thanks for joining. Hope you have a good one, and keep on rocking it in science.